Good afternoon, everyone. We'll give everybody a few minutes to get in here. Start maybe here just a couple minutes, just trying to give people time to get in. We'll get going here in just a second. Once you're in, please put something in the comment box just so I know who is here. Thanks so much. All right. Good Monday afternoon. Ooh, sorry. Sorry about that. Good Monday afternoon to everyone. Let's see. I have Cypress Dublin 10712577876 in, and that's AKA Josiah today. I got Dom, Kelsey, Maddie, Kristen, Bernice, and Lucy is who I see thus far. If you're coming in late, hey guys, just type something into the chat box, just saying, "Hey, I'm here," or whatever. Let's go ahead and get started. First, we'll start with lesson 5.4 homework. Questions on that before we move on to 5.5 notes. Questions on that? Kelsey says number 10. So work number 9, and I guess number 10 would be the other challenging one of this problem. Bernice says 10. That's cool. We'll look at number 10 then for you guys. Okay. So look at number 10. And I think I started to set this problem up for you guys. So what we said was add the square root of 4 minus r to both sides. Add the square root of 4 minus r to both sides. Okay. Cancels there, and I have radical 4r minus 3 equals 2 plus radical 4 minus r. From there, I would square both sides, right? Square both sides. Over here, I get 4r minus 3. The square root and the square just simply cancel each other. And over here, I square this side, and I have 2 minus radical 4 minus r times 2 minus radical 4 minus r. And, of course, we need to FOIL that right side. So first, 4, that's simple. Outside, minus 2 radical 4 minus r. Go inside, minus 2 radical 4 minus r. And go last, which would just be plus 4 minus r. Should look something like that. Then from here, I got 4r minus 3 is equal to 4 minus 4 radical 4 minus r. I can combine these two. And negative 2 minus 2 is negative 4. Treat radicals like they're variables. And then plus 4 minus r. Then I can combine the two 4s. 4r minus 3 is equal to 8 minus 4. Maddie said the 4 before the radical should be positive. One, two, three. What line are you talking about, Maddie? Oh, you're saying this 2 right here. I think that's what you're saying, the 2 here on line 2, right, Maddie? So going back to line 1, 2 times 2 is 4. 2 times negative radical 4 minus r would be negative 2 radical 4 minus r. Then go inside, that would be negative 2 radical 4 minus r. And then a negative times a negative would be a positive, and then what's ever on the inside, 4 minus r. Oh, gosh, I see what you're talking about. Where did I get that from? So this should be positive. Sorry, guys. I'm looking at, I didn't write that problem down right. Don't worry, man. I'm doing horrible today. So this is a plus sign, not a minus, so both of these should be plus. I'm with you now. So 2 times 2 is 4. 2 times that would be positive 2, right? Outside and then go inside, that should be a plus 2. And then plus 4 minus r. So all that's still good. It just changes, should just change this right here. So plus 4. 2 plus 2 is 4. And then that takes me to 8 plus 4 radical 4 minus r minus r. Is my line 4 correct, Maddie? I think I'm right now. Sorry about that, guys. Copy the problem down wrong. Looks right to me as well. Okay, cool. Sorry about that, guys. So now let's subtract 8 from both sides. Let's subtract 8 from both sides. And let's add r to both sides. We know they cancel over here. We got 5r minus 11 equals 4 times radical 4 minus r. What'd you all do from here? Square both sides, or did you divide by 4? Type that into the chat box. Did you square both sides here, or did you divide by 4? Okay, you guys said you went ahead and divided. Okay, I couldn't remember what we did on the other one. So this cancels right here, divided by 4. And then, yeah, you could do either way, Lucy. And then let's go ahead and square both sides. The square root and the square cancel here. And I'm left with 5r minus 11. 5r minus 11. All over 16, because you got to square the numerator and the denominator is equal to 4 minus r. I'm now going to multiply both sides by 16 to get rid of the fraction. Cancels, cancels. And now I'm going to FOIL this. 25r squared first, outside negative 55r, inside negative 55r, last, plus 121 is equal to 16 times 4 is 64 minus 16r. If I combine that, I get 25 minus 110r plus 121 equals 64 minus 16r. If I subtract 64 from both sides and add 16 to both sides, we know that cancels and that cancels. And then I'm going to kind of move the paper to over here. Yeah, don't forget r squared. Thank you. So then that takes us to this. 25 r squared negative 116, or excuse me, negative 110 plus 16 is negative 94r. And then 121 minus 64 is 57. And of course, all that's equal to 0. Is this looking right so far? 25r squared minus 94r plus 57. Anybody else get that? I just want to make sure we're on the kind of right path. I'm kind of flying through here. So Lucy's with me. Cool. Okay, cool, cool. Now, what'd you all do from here? Did y'all do quadratic formula, or did you try to factor it? Josiah said factor. Everybody else said quadratic. 25 times 57 is 1425. So what will multiply to be that, but add to be negative 94? Anybody? What factors did you get there? Negative 75 and negative 19. Okay. If you follow the quadratic formula, opposite b plus or minus the square root of b squared minus 4ac all over 2a, that as well can get you there. Okay, going to be dealing with big numbers no matter what we're doing. I'm going to trust these guys, and I'm going to go with 25 r squared minus 75 r minus 19r plus 57. Then just factor by grouping. All right. From there, I can factor 25r out, and I'm left with r minus 3. Over here, I factor out a negative 19, and I'm left with r minus 3. Sorry. Yeah, I see that it's blurry. Okay, sorry about that. So we need to say 25r minus 19 and r minus 3. And then from there, we need to just say 25r minus 19 equals 0. That's going to be r equals 19 over 25 and r equals 3. And then we'd have to check for an extraneous solution. And did anybody check those? Is one of these extraneous? Okay. All right, so 3 is our answer. Okay, r equals 3. 19 over 25 does not work. It's extraneous. Does that help you all on number 10? Give me thumbs up. Yes, no. I know it's a lot. Kind of shot through it kind of fast. Okay, and then Josiah said that Sosa wants to see 4. So if I'm working 4, my first step would be divide 4 on both sides first. Cancels there, gives me 1 equals radical negative 1 minus n. Square both sides. Cancels, cancels. And I get 1 is equal to negative 1 minus n. Add 1 to both sides. I get 2. 2 equals negative n. N equals negative 2. Four equals 4 times negative 1 minus negative 2. So that's plus 4 equals 4. Negative 1 plus 2 is radical 1. 4 equals 4. So negative 2 works. Okay. Hope that helps, Sebastian. I know you're not in, but hope you're seeing that. All right. Let's jump to the next one. Elena says 7. So with 7, square both sides. You get x minus 3 times x minus 3 is equal to 6 minus 2x. That's x squared minus 3x plus 9 equals 6 minus 2x. X squared minus 6x plus 9 is equal to 6 minus 2x. Add 2x to both sides. Subtract 6 from both sides. Cancels, cancels. X squared minus 4x plus 3 equals 0. What will multiply be 3? Add to be negative 4. Negative 3 and negative 1. X minus 3, x minus 1 equals 0. So that's x equals 3 and x equals 1. Three's good. Doesn't look like 1 would be good, though. Yeah, one would make that -2. One would make that 4, or square root of 4, which is 2. X equals 3 would be our answer. That makes sense. Who is that? Elena? You making sense of that? Cool. Abby said number 8, please. So look at number 8. So what I would do first with 8, because I don't want to square this with this in here as well, I would just subtract 2 on both sides. So b minus 2. And then let's square both of these. That's 2b minus 5 equals b minus 2, b minus 2. 2b minus 5 equals, when you FOIL that, you should get 2b minus 4b plus 4. I skip one step, but you should, when you're FOILing the same thing, it's just going to be that outside -2b and -2b. So they're always going to produce that same middle term there. Okay. Subtract 2b, add 5. Zero is equal to b squared minus 6b plus 9. Multiplies the 9, adds to be -6. Should be -3 and -3. B minus 3, B minus 3. It's a perfect square trinomial. So just B equals 3. And that would work. You good with that, Abby? Any questions on that? Any of the questions on 5.4 homework? Any other questions on 5.4 homework? If you are, give a question. If you're good to move on to lesson 5.5 notes, go ahead and just shoot me something into the chat box. Looks like we're all good. Okay. Going to lesson 5.4 notes. We'll put that out. Spent about 30 minutes on that review, so that's fine. This shouldn't be too bad today. So thumbs up or smiley face once you're ready for this. Okay, I know I just asked you to do one for that. But if you have this out, you're ready to go. Give me thumbs up, smiley face, whatever. Okay? All right, here we go. So what lesson 5.5 is over is function operations. So when we have two functions, for instance, like f of x and h of x. These are two different functions. And what we're doing with these two are operations. Operations such as adding, subtracting, multiplying, and dividing. So when you have two functions and you got to operate within them, okay? So when we're given two functions and we have to do operations, okay, so it says perform the indicated operation. H of t is equal to negative 3t minus 5. G of t is equal to 4t minus 3. It says find h plus g of t. So that's saying like in terms of t. Find it in terms of t, or with t being, in terms of t is just leaving t as itself. All right. So this is actually pretty simple here. We're just going to say the first function, h of t, negative 3t minus 5 plus g of t, which is 4t minus 3. And then we just combine like terms. Negative 3t plus 4t is t. Negative 5 minus 3 is negative 8. And that is this in terms of t. It does not equal 0. No, it does not, Maddie. So function operations is just taking two separate functions and adding, subtracting, multiplying, or dividing them. Not too bad. Let's look at number 2. Here's h of n, g of n, and it says find h plus g. Now notice over here it said in terms of t, but this is saying in terms of negative 5. Okay, so let's set it up the same way. Let's say negative 4n plus 5 plus 3n plus 2. All right, but here's the difference. This, we solved it in terms of t, so just keeping t as what it is, but this, we have to solve it in terms of negative 5. So we're just going to substitute negative 5 for n. So negative 4 times negative 5 plus 5 plus 3 times negative 5 plus 2. So we just substitute whatever's here in terms of negative 5 for that. So we say that's positive 20 plus 5 minus 15 plus 2. Is this like substitution? Substitution is I guess it would be more of a step. Yes, in this part you do substitute the -5, whatever's here, for the n, Elena. Twenty plus 5 is 25. 25 minus 15 is 10. And 10 plus 2 is 12. Questions on 1 or 2, adding function operations. Questions on 1 or 2, adding function operations. If not, give me thumbs up if you're ready to go. Smiley face, something like that. Good, Elizabeth. Good, Abby. Good, Christina. Good, Maddie, Dom. Good, Bernice. Kristen, Caitlin. Lulu. Josiah. And Josiah, we weren't really hating on your mom's name, dude. You can get on your mom's account. That's fine. Just want to let you know. All right, look at number 3. Now we have g of t and h of t, and it says find g minus h of t. So here we go. And we're going to say g of t is 4t. That's our g. Minus h of t, which is negative 3t plus 4. But since this is g minus h, I'm going to have to put this in parentheses because that's saying g of h minus all of h of t. Then let's distribute to take care of that. We get 4t plus 3t minus 4. Correct. Only when it's a subtraction. Okay. And if you go back to all the lessons we've done with, like, when you subtract two things, you always got to put whatever's to the right in parentheses. So that's just with subtraction. Okay. And then 4t plus 3t would be 7t minus 4. And we're solving this in terms of t. So we can say 7t minus 4. Okay, so Abby's saying, what if 3t was positive? So let's say it was 3t plus 4. This is an example, and 4t. And let's say this was g, this was h, and it was g minus h. Then we would do the same thing. 4 of t minus 3t plus 4. And then we would distribute the negative in as well. Does that make sense to you, Abby? you're always just going to say minus the quantity of when it's subtraction, because you've got to distribute that negative in there. The only time you wouldn't put this in parentheses was if this h right here was a monomial. If it's a monomial, it's not going to impact it. But since it's a binomial, you'd have to do distributive property. Elizabeth says, why don't we divide the 7 out? There's nowhere to divide it. It's not an equation, Elizabeth. It's an expression. So you don't have to do, that's all you have to do. There's nothing else you can do from there. Okay? Does that make sense, Elizabeth? Elizabeth, okay, you said yes. And then Christina said, what is this? And like, how does it, I love how she said, like, how does it apply to a graph? Okay, so good question. How does this apply to a graph? Well, let's just, let's go to a graph and let's look at what this, if there's any correlation of it. Turn my brightness up just a little bit. So if I'm looking at this and I'm saying like 4x and negative 3x plus 4. If I graph that, I know these are just two lines, right? Okay. And then if I graph just what we found, 7x minus 4, and I graph that. Christina, do you see any significance to it? I don't see any significance to it personally. And I wouldn't use a cliche of works, I'm expanding your knowledge. It's really just more in terms of that when you have different functions, different linear equations, quote unquote, that you can operate within those two. Okay. But in terms of the graph, not much. All right. Number 4. F of t equals 2t squared plus 2t, and g of t equals 3t minus 1. Find f minus g of negative 1. So I'm subtracting here. So I'm going to say 2t squared plus 2t, and then minus, since this is a binomial, I have to say the quantity of 3t minus 1. Distribute. And we say 2t squared plus 2t minus 3t plus 1. Now, if you notice on this last number 2, we actually plugged it in on our second step. You can plug negative 1 into t here, or you can simplify first and get 2t squared. 2 minus 3 would be negative t plus 1. So you can combine like terms first and then plug it in, and that'll kind of keep you from plugging it in possibly more than a couple times. So then in this problem, we got to plug it in a couple. So 2 times negative 1 squared minus -1 plus 1. So -1 squared is just 2. And sorry, that's a -1 right there, isn't it? That's a -1. So then negative times -1 would be a +1. And then plus that one there. Our answer should be 4. Okay. Moving right along. If there's no questions, looking at number 5. 5. So we've done addition, subtraction. Now we're at multiplication. All right. So it says this is f of x, this is g of x. Find f times g of x. So that would look like this. 4f of x is 4x plus 5 times g of x, 4x minus 3. And it said solve it in terms of x. So that means you're not plugging anything in. Just solve it in terms of x. And I would have to FOIL this right here. So we go first, 16x squared. Outside, -12x. Inside, 20x. Last, -15. -12 plus 20 would be 8. So 16x squared plus 8x minus 15. And we don't have to factor it. We don't have to do anything like that. It's just saying multiply those two together. If we factored it, it would take us right back to this right here. Okay? So that's all it's looking for. Multiply those two. Okay? Going to the next one. Number 6. I have 4x. It's saying multiply those. 4x minus 2 times x squared plus x. Okay. Now, it says find this in terms of -3. So here's my question. Should we FOIL it right now or just go ahead and plug in -3? Type that in the chat box. What do you think? So Josiah says FOIL. Maddie says FOIL. Abby says plug in now. Christina says plug in now. Elizabeth says plug it in. It gets weird if you don't. Okay, yeah. So we got some different things. So let's FOIL it. So let's FOIL first. So here we go. First would be 4x cubed. Outside would be plus 4x squared. Inside would be minus 2x squared. And last would be -2x. Okay, so 4x cubed, 4 minus 2 would be 2x squared minus 2x. And then let's, from here, I mean, we can factor something here. We could factor out a 2x. We could kind of go that route, or we can just plug in -3 from here. So 4 times -3 cubed plus 2 times -3 squared minus 2 times -3. Okay. That will be 4 times 27, or excuse me, -27 plus 2 times 9, because -3 times -3 is +9, but 9 times another -3 would be -27 plus 9, and then plus 6. So -27 times 4 would be -108. So -108 plus 18 plus 6. Plus 18 and then plus 6. Plus 18 would take us to -90. Add 6 would take us to -84. Kelsey's saying plug in for simple multiplication. So if we did plug that in, it'd look like this. I'll do it with a different color. 4x minus 2 times x squared plus x. Oh, no, you're fine, Kelsey. 4 times -3 minus 2. And then -3 squared plus -3, which is just basically -3. That's -12 minus 2. And that's 9 minus 3. -12 minus 2 would be -14. And then -14 times 6. And that would take us to -84. You guys know I'm a person of I want to eliminate as much work as possible in order to eliminate room for error. So in this case, I would probably plug it in from the second step. Just know that even though, and again, this is just a matter of opinion. So even if you like this way better, that's completely fine. Just know you still will get the same answer. Questions on 5 or 6, multiplication. Seeing no questions, let's move on. Okay. Now looking at number 7. So number 7 says is division. It says this divided by that in terms of t. So g is the numerator, 3t plus 2, over f is the denominator, t cubed plus 2. Can I factor, or can I cancel those 2's right there? Can I factor the numerator or the denominator, or could I even cancel those 2 2's right there? Type it into the chat box. Maddie says no. Elena says no. Caitlin says no. And then we're getting a slew of no's. Lucy, Bernice, Christina. Very good. So I can't factor this. I can't cancel those 2's because they're attached with the addition. They're attached to that 3t with addition. So, folks, that is our final answer there. All right, looking at number 8. Number 8 is the same way, but we need to evaluate it at -3. So -4t minus 4 over 3t cubed minus 3t squared. We come to the question, do we plug negative 3 in now, or should we factor this and then plug it in? Sorry, thank you, Abby. Elizabeth says plug it in. Maddie says plug it in. Plug it in, plug it in, plug it in. All right, so you are all saying plug it in. So 4 times negative 3 minus 4 over 3 times negative 3 cubed minus 3 times negative 3 squared. This would be negative 12 right here. So negative 12 minus 4 would be negative 16. This would be 3 times negative 27 minus 3 times 9. Three times negative 27 would be negative 81 minus 27. Negative 81 minus 27 would lead us to negative 108. Does 16 go into 108? It does not go evenly. We know 4 will go into both. 4 will go into that 4 times. And a negative by a negative is a positive. And 4 will go into that. Think of 4 will go into $1.25 times. So it'll go into that 27 times. And then 4 won't nothing. Nothing will go into 4 and 27. So that appears to be our final answer. Questions on division. All right, let's go to the back. Okay. So on the back, I'm actually going to come down here. Let's go down here below 11, and let's just take some quick notes. So let's talk about composite functions. These are what we call composite functions. Okay. And what composite functions are, they are the result. They are the result of applying the rule for one function to another function. Okay. You're going to see this little symbol that looks like this. in between f and g. And this is the operation. This is the operation called computation of functions. Okay, so here's what that looks like, guys. Composition. Did I say it wrong? Yeah, composition. Composition. My goodness, I can't even say it right now. Yeah, composition. Thanks, Elena, for pointing out my faults. You and Twitch, you and Abby, you guys keep me humble. So, all right. So now, looking at what that looks like. So here's what it looks like. You're gonna see a couple different things. Okay, you could see something that looks like this. F composed, that just means composed with G of X. Fog, right? That is actually telling us to do this right here. F of G of X. Okay, so, and if you legit think about what's happening, composing would be to make something whole or to create something. So here's the way I want you, anytime you see something like this, I want you to think about it like this. You're plugging G into F, okay? You're plugging G into F. And if it was the other way around, if it was G O F of X, G composed with F, that's just saying G of F of X. Plug F into G. Okay. Coming to 9. Abby, I just saw your comment about composition. That actually was pretty good. Not too bad. Notice how I compliment you, but you attack me. Okay, so let's look at number 9. So here's G of X. Here's H of X. We're going to plug, what does G compose H of X mean? That means to do this. G of H of X. Now, if you're literally looking at this, that's saying put H of X into the X of G of X. Sorry. Okay. So, again, I'll explain that again because it got a little blurry. It's saying G composed with H of H. So we're going to plug H of X into the X of G of X. So plug H into G. All right. So I'm going to write this out. G of X is equal to 3X minus 4. And H of X is equal to 4X plus 4. So we're putting H of X. This is H of X. We're putting it into the X of G of X. Now, if there was more than one X here, we would plug it into that as well. So then we get this. 3 times the quantity of 4X plus 4. That's that into that X, then minus the remaining 4. So then from there we distribute 12X plus 12 minus 4. 12X plus 8. And that's all I have to do right there. Correct. So really nothing new, just besides the fact that you guys, the composing functions or bringing two functions together, composing them. And that composing functions is just under that same umbrella as operations of functions. So we can add, subtract, multiply, divide, and compose them as well. All right, look at number 10. So plug H into G. So that would look like this. -2 times 3X plus 5 minus 2. -6X minus 10 minus 2. That's -6X minus 12. Somebody was about to say, do we need to factor that? I know you were. I knew it. I knew there had to be some people that were thinking, man, do I need to factor that? That's good. I'm glad you get, again, I told you at the beginning, I need you to be factoring machine. So anything you see, you need to think factor. All right. So let's go to number 11 now. 11, G, F of G. So put G into F. So that's 3 n squared minus 5n, and then minus 5. We get 3n squared minus 15n minus 5. And we don't have to worry about factoring that or anything. We're just expressing it like that. Okay? Last one, number 12. F compose G. Put G into F. So 3 times 2n plus 4 squared minus 3. Now notice we're not solving this for n here. We're solving it in terms of -1. So should I go ahead and FOIL this out and simplify it and then plug it in, or should I just plug it in right now? Yeah, plug it in. So 3 times 2 times -1 plus 4 squared minus 3. That's 3 times -2 plus 4 squared minus 3. Who has the answer? Someone type it in. 3 -2 plus 4 is 2 squared minus 3. 3 times 4 minus 3. 12 minus 3 is 9. Very good, Maddie. Very good. All right. That's it for lesson 5.5 notes, function operations. Of me. You guys are free to go. Thanks so much for being here today. You guys are here. Everyone's here every time, and I appreciate it so much. Hey, quick question, though. Quick question before you do leave. Yeah, I can bring 12 back. I'm sorry. Quick question before you leave. Do any of you all have chemistry during like the times we've been having class? Does any of you, I got 2 of you saying no. Does anybody? So, Dom, you do? Okay. Hey, so Dom, I think the way. Oh, okay, Dom, you have it at 8 a.m. Man, so you guys getting up early. Anybody else have it like while we? No one else. So it's not impacting anybody in here. Okay, then I'll spare you all the details. Okay, that's cool. Yeah, we're trying to work it out where we're not where we're doubling up on people to be at 2 places at once. That's the only reason I asked. I was just going to tell you, go to Miss Ray's class, don't come to mine, and then just watch my recorded version. Does the Zoom record your class so you can go back and later and watch it? Man. Okay, so like right now you can go back and watch a Zoom class. Okay, cool. Man, I don't see what the issue is then. But okay, answer your question, Lucy. So whenever we have a number, should we just plug it in at start? I would say yes to that. Yeah. I'm not here to know when she starts it or if she, records it or whatever. Lucy, your example would be like number 2. If you combine those first, it might make it a little bit easier. So, but most of the time, once you have your number, just plug it in from the start, or else it could end up like 6, and you could go through a ton of stuff. So, any of the questions of me? I hope you guys are doing well. Continue to do well. Hope this is not too crazy for you. Hope you're staying indoors. Good luck. May the odds ever be with you. Good day to all of you. Thank you, Maddie. Have a good day. Good day, Dom. Good day, Bernice. Good day, Abby. Good day, Christina. Please don't ever put those on this thing again. Good day, Elizabeth. Good day, Kristen. Good day, Caitlin. Any other questions, guys? Any other questions of me? Give you a couple minutes to type if you're typing.